It's a point on your line.
Can I elaborate? Yeah, it's when the lines intersect. So we're going to actually today learn how to find the solution with the coordinate where the lines intersect without actually graphing it.
Yes.
Yeah, the graphing part's never the fan favorite.
Alright, so Sienna wrote these equations to help solve a number riddle. What values for x and y solve both equations?
So again, this is a system because it's two equations. Okay, they're both linear equations, and there's two of them. This is a system.
What does y equals x minus 20 tell you about the relationship between x and y?
That whatever number you put in the x, you have to subtract from 20 to get y.
Yeah, so whatever number you put in for x, y is that number subtracted by 20.
So like, give us an example. If x was what? If x was 20, what's y? 0. What about if x is 30? Good, because whatever you have for x, you would just subtract 20 from that to get y. That's what that tells you.
Okay, so what does x plus y equals 84 tell you about the relationship between x and y? Yeah, so whatever x and whatever y, when you add them together, they're going to equal 84. So give me an example for that. Give me two numbers that would equal 84.
16, 24.
Good.
So 60 and 24.
Any others? How about 80 and 4? Yeah, there's many options.
83 and 1, yeah.
83 and 1, 84 and 0.
So what do you know about those? Well, so like 83 and 1. What does that tell you about this equation? If 83 is x and 1 is y, what do you know about those numbers?
83 is x and 1 is y. Oh, I thought you were about to say 83 is x. I thought you said 83x plus.
No.
Plus 1. I was like.
So what do we know? If we know that any of those solutions that you came up with for this equation, what do we know about that? Like when we graphed it, what do you know about that x and that y that we came up with that solved this?
Yeah.
I'm just recapping. We already talked about this. What do we know about that x and that y? Like someone said 80 and 4, someone said 50, what did you say, Marco? 60 and 24.
How do you know their solutions?
Because they both add up to 8.
Okay, and where would they fall if we graph that line? Where are the solutions?
We graphed it.
Would they be where?
Point on the line.
Maybe on the line. Every coordinate on that graph is a solution. Does it have to be whole numbers? No, it could be a fraction. It could be 80 and a half plus 3 and a half. Right? That would be a coordinate on your line.
Alright, so could we guess and check to find the solution to this system?
Because think about what we need. Okay, so for the first equation, we need two numbers, an x and a y. Whatever x is, y is going to be 20 less than that. Okay? But then in addition to that, whatever those two numbers are, they need to add up to 84. That's the system. It's like a puzzle. You're trying to find, you came up with examples for both, but now you need the one example that works for both. So you need a value of x that if you took 20 away would give you your y value. So you're looking for two numbers that match that criteria. But then they also need to satisfy the second criteria, which is if you added the two numbers together, they would equal 84. Could we just guess? Could we use the suggestions from the first example, like 50 and 30? Could we use that? Could we say 60 and then 60 minus 20 is 40? Could we just guess and say like, okay, well these numbers work for the top one, so I'm gonna like just try them for the bottom one. Could we do that?
We could, but it would take too long.
It would take long, but let's try.
Let's try it. So this says try 44 for x and 40 for y. So how would I try that? Start with the first equation.
Is that gonna work for either one?
For one of them,
Which one?
the second.
Why does it work for the second one? Because if I substituted the values in, 44 for x and 40 for y does equal 84. So that one would be good. Does it work for the first one?
No.
Why not?
44 minus 20 is
Is
Because 44 minus 20 is not 40. And that's a really a great way to say it. It's 44. If I substitute in 44 for x, 44 minus 20 does not equal, and that's not equal, the equal sign with the line through it, does not equal 40. So is this a solution for the system? No.
Alright, so now let's try 50 for x. Let's try the first one. So 50 is x in that first equation. What do we have for y? 30. Okay.
So we think 50 is x and 30 is y.
Now let's try it for the second one. So 50 is x and 30 is y.
adding those
no, it would equal.
Doesn't-
That does not work.
So is it a
Not
solution
equal.
for the system?
No.
No, because if it's not a solution for both, it's not a solution for the system. It could be a solution for just one of them, but that's not what we need. In this unit, we need it to be a solution for both.
Okay, so now let's try x is 52. So x is 52. 52 minus 20 is
32.
32. Alright. That's different.
So that one
We'll see if
says,
that works. I mean,
how does it work in the bottom one?
It works
It works. How do you know it works?
because if you substitute 52 and 32 for x and y, you would get 84.
Good, because 52 plus 32 does equal 84. So if it works for both, is it the solution for the system?
Yes.
Yes, and it's the only solution for the system. How do we know that this system only has one solution? How do we know the system only has one solution? What's our criteria if we're looking at equations to determine if there's only one solution? Look back to your notes. One solution is what?
Is different slope and same line.
It doesn't need to be the same y-intercept, so if you have it written down, cross it out. Different slope. Do those have different slopes?
Yeah.
They have different slopes because what's the slope for the first equation? No, just the equation.
the slope for the equation.
What? 20 and 84.
Nope, we're looking for the slope. 1, because y equals x. The coefficient of x is your slope. There's no number there, that's 1. What's the coefficient of the second equation?
Oh wait, no.
Negative 1.
How do you know it's negative 1?
Because if you want 1 by itself, you have to subtract x from both sides.
If you put that equation into slope-intercept form, and that's how you would want to explain that. If you put it in slope-intercept form to identify the slope, y equals negative x plus 84. So that would be a negative 1. That's how you know there's a solution in the beginning, because the slopes are different. And we just found it. You found that if x was 52, y was 32, so you found the coordinate that they both share. Is guessing and checking the method you want to use?
No.
No. I hope not. But graphing sometimes doesn't make sense, because if you graph that, your x would have had to have been 52 and your y would have been 32. That would have been a monster to graph. So we have another option. There's a few options, but we're going to talk about one today.
So yesterday and the day before, we learned how to tell one solution, no solution, and knowing many. So we just talked about how to tell if it's one solution. How do we know?
Only different slope.
Yeah, they have different slopes. If they have different slopes, then we know that that system has one solution. Right? What about no solution?
Do any of the systems up there have no solution? What does it mean for no solution?
When they have the same slope.
Same slope at a different y-intercept. Do either one of them have the same slope and a different y-intercept?
5x.
How do you know?
5x and 5x.
But how do you know it's not a scenario like we just had where it looked like they were both x but one of them was actually negative?
Oh,
Because that's what it looks like to me. You can't identify the slope unless you're, well, okay. If you're going to look at the coefficient of x to determine your slope, your equation needs to be in slope-intercept form. Otherwise, the sign can get a little crazy. Can you put both equations into slope-intercept form? The one on the right.
Everyone try right now. Put both of these equations in slope-intercept form.
So 5x plus y equals 3 is not in slope-intercept form. How do we get that to slope-intercept form?
Subtract.
By subtracting.
Subtract the 5x. So if I subtract 5x from both sides, how do I rewrite my equation?
Y equals negative
We have
5x
y
plus 3.
Y equals what was it?
Negative 5
negative 5x
plus
plus 3.
So what do you notice now about those two equations?
That there's
Their slope is the same, and what do you see about their y-intercept? So what's the solution? No solution.
What about the other system on the board? Everyone take a look. So notice that they're both not in slope-intercept form. That neither of those equations say y equals mx plus b. So I want everybody to take a look and see if they can find, if they can put these in slope-intercept form, and then see if you notice anything. So tell me what these were when you put them in slope-intercept form.
the first one was y equals negative x plus 6.
Alright, can somebody tell me what the second one is in slope-intercept form? So we have 2y equals negative 2x plus 12. Is that in slope-intercept form?
No.
Why not? Because y is not alone. How do you get y alone here? Okay, so if you divide y by 2, what do you do to the other side?
You have to divide the
Divide the whole thing by 2, or every single thing by 2. So what does that become?
Y
negative x plus 6.
So what do you notice now?
It's infinite.
An infinite number of solutions. Good.
Okay, so the system has definitely have a solution. So you can guess and check, but it's usually not an effective way to solve. Why, Manny? You told us in the beginning. Why do you think guessing and checking is not an effective way to solve?
I'll take 2.
Yeah, it'll take a really long time. You might have, it might be a fraction. The solution might have a fraction in it. So if you went through and you had to do like 1/8, 1/16, it would take forever. Alright. So you could graph, we learned how to graph the last 2 days that we worked on this. We learned that we can graph it, but it might go off the graph sometimes. So that's, we can do it that way, but it's not always gonna be easy. So one way to solve this is by using substitution. So this is one method.
My favorite method.
This is a favorite method. Alright. So based on the two equations, is there any value for y that you are given? So based on these two equations, is there any value for y that you are given?
What do we know about y? Okay, so we know that, say it again.
That y is 20 less than.
Okay, so is there a way that I could represent y differently? Like instead of a y, is it something else? Could it be? What kind of equations do you know how to solve for? How many variables are in them? You've solved them?
You can solve an equation like this with two variables.
Think about the equations you have solved so far, like in Unit 1.
Think about that equation that we solved earlier.
There's usually how many variables? There's usually just one. But now the problem is we have how many? 2. So we don't want there to be 2. We want to represent this in one variable. So if I know that y is really 20 less than x, can I just write y differently?
Minus 20.
So look at that top equation. What does the top equation tell you?
X minus 20 equals 1.
So x minus 20 equals y. Okay. So that means that y is what based on that? Y is,
Y is equal to.
just read the equation in words.
Y is equal to x minus 20.
So the value of y, whatever y is the same as x minus 20.
Yeah. So y could be negative.
Oh, don't think of values yet. We're still trying to find a way.
The word substitution, what does that mean to you? Like, let's say you have a substitute teacher come in. What is a substitute? Yeah, it replaces the other teacher, right? So what do we think we could do here? If we know that y is equal to x minus 20. Y is x minus 20.
Is there something we can replace to make our equation just one variable? Either one.
Value for y.
What is the value for y? What's the only value for y that we know just by looking at the equations? Y is what?
X minus.
Y is what? What's the only thing we're told? What's y?
X
X minus 20.
So y is x minus 20. So does that mean that anywhere I see a y, it's really just x minus 20?
Yeah. So can you do x plus x minus 20 equals to 1?
Why did he do that? What did Gustavo do?
Like you already know that y is x minus 20. So instead of having x plus y equals 84, replace y
Or
with x
substitute.
minus 20.
So
Just to
he
make it
substituted the value for y because anywhere, that top equation tells you anywhere you see a y, it is x minus 20. They're the same thing. Which means anywhere you see a y, you can just replace it. Why would you do that in that equation? Can you solve that equation?
Yes.
Why can you solve that equation now in that format, but you couldn't when it was just x plus y equals 84?
Yeah. You have 2 variables.
And what do you have now?
Just one.
Now you have one variable. Solve that for x.
2
2x.
x. 2 x. Plus 20.
I hear someone walking me through it. I just don't know what it is.
So 2x equals 104, which means 1x is what?
52.
Okay. So you just found a value for x. If x is 52, what's y?
Now,
Nick.
Because this isn't the solution for the system. We only have one of the variables. What do you need to find now? You have the value for x, but you're not done. There's still another value you need to figure out. What is it?
Another x.
y.
We need to find y. If you know that x is 52, Gustavo, what's y?
It's 32 because yeah, it's 32.
How do you know it's 32?
Because I used the second one. It's like it's easiest one. So 52 plus 32 is equal to
So what'd you do with the x? Where it says x is 52, what'd you do?
I plugged in 52 because x is 52.
So he substituted in that value for x of 52 into one of the equations. You could you can do it to either one. What do we know about the solution to the system? What does it represent? It's a coordinate
Where both lines intersect.
that they share. They share the coordinate. So x would have to be 52 in both equations. And y would correctly check out, like Gustavo said, to 32. So this isn't, the concept may be new, but the idea isn't. You've substituted quite often. If we give you values, especially in like the last unit, we substituted values into equations so we could graph it. Now you're actually going to substitute based on an equation that you're given.
So we just found the solution to the system without graphing.
Algebraically.
It feels bad.
Alright, so this is exactly what we just did.
We proved it.
Substituted, yep.
We did that.
Alright. Okay, so now,
Hands on.
We're going to use algebra tiles for this. Sometimes the idea of substitution is a little bit easier when it's hands-on. So just share these with like one other person. And I know you've used these before, or maybe you don't remember this. But for the purpose of this, listen please. I'll wait. For the purpose of this little hands-on activity, your x will be the rectangle as it always is. But your y is going to be the big square. That's normally x squared, but for the purpose of this, it's going to be big square. And then your constant is going to be the little square. So monovolt. We'll kind of go through it together. Monovolt equations. You have 2x plus y equals 7. And then y equals 3x plus 2.
so y is this. Yes. So like the number
Oh, you spelled my name right.
Take out the bag. Give Aaron that. Give him
Do we have these models? Your model should look something like what's up on the board.
What brand did you say?
Does everyone have like what we have up there? We have 2x and y. We don't have to show the plus symbol because naturally they're together, that would mean addition. So 2x and y equals 7. And then y is 3x plus 2. If you were going to physically substitute, what would you physically move? What could you replace? 'Cause here's the
Excuse the
problem.
interruption. Miss Moscow, please report to room 13. Miss Moscow to room 13, please.
How many unknowns do you have here?
Miss Mossman.
Like in this equation, how many unknowns are there? Just one?
Two.
There's two. This rectangle, we don't know what it's worth, and the big square, we don't know what it's worth. We don't know the x, we don't know the y. Right? Is there something I could replace? What would you replace or substitute into that equation to figure out the value of one of the variables? What would you replace? Okay, what would you replace the y with? With what? Just 3x?
3x.
So this one big square has the same value as this whole thing. That's what that equation tells you. Y equals 3x plus 2. This one big square is the same thing as that. So we're going to replace it. We're going to move it over. Don't forget this guy. We're going to... So we physically, you all do this at with your tiles. Replace the y. Does everyone see why we are replacing that large square with the 3 rectangles and the 2 tiny squares? Because that's the key to substitution. Do you understand why you're allowed to do that? And if you don't, it's okay. Let us know now. Substitution, when you first start it, is a little like crazy. And then once you get it, it's like, oh, well, that makes sense because they have the same value. So how would you now find the value for the rectangle? Think back to your work with tiles. What could you do? Because this says, what is this equation now? Rewrite that equation for me.
Well,
Okay.
Come on, girl, I hear the girl saying it.
simplify the 5x
Plus 2. 7. Okay. How would you solve that? Using tiles, but also same idea using algebra. What would you do? Be specific in how you're saying it, because you're saying it a little different.
Well, like, you know what? So, like, the positive 2 being subtracted,
How do you get rid of it?
subtract by negative 2.
You're not subtracting a negative 2. What are you taking away? You're just taking away. Well, just tell me the number.
A 2.
Yeah, like you're making it a negative. That's not a negative. To get rid of that, you take away 2. So with your tiles, you take 2 tiles away. If you take 2 tiles away from the left, what do you have to do to the right?
Take 2 away.
Why do you have to take 2 tiles away?
Whatever you
Then
do,
the-
always like the
You know, right?
Yeah, to keep it balanced. So now what?
9x equals
So what's 1x?
1x.
5.
What does that equation say?
It says 5x equals 5.
So what's one of them?
1 over x.
1. It's like for me to, 1 goes there, not that. 1 goes there, and this is what you do with your algebra tiles. Getting a little crazy. So 1x is 1. So x is 1. You divide both sides by 5, which is what we just did with our tiles. X is 1. If x is 1, what do we have to do to find y? If x is 1, what are you going to do to find y?
We know the value for x. We have 2 equations up there. How do we find y?
Substitute the 1 of x in the equation.
Okay, into which one? Does it matter? No, you can do either one. Because what do we know about the coordinate where x is 1? We don't know y yet, but what do we know about that coordinate? Which equation will it work for? It'll work for both because it's a solution to both. That's what makes it a solution to the system. So if x is 1, what's y? If x is 1, what's the value for y? How do you know 5? Which one did you do? You did the one on the left, and what'd you get? Yeah, so you substitute in the 1 for x, so it's 2 plus an unknown is 7, so you knew that the unknown was 5. The actual substitution is the way to solve. This is one of the ways to solve. So what did we need? How do we need the equations to be written in order to substitute easily? I use the word easily very lightly because I know it's not easy since you're just seeing it for the first time. But what makes the equation on the right easier to use for the substitution part than, say, the equation on the left? So it's already in slope-intercept form, which means what do we already know?
Yeah, whatever you plug in for x, you'll find the solution for y.
Well, no, go back. Because that equation's in slope-intercept form, why is that more helpful to use for substitution than the equation on the left? What do we already know on the right? The value, the y. We already know that y is 3x plus 2. Do we know just by looking at the equation on the left what y is? Do we know what x is? Before we calculate. No, not in the beginning. Does it need to be y equals, or could the equation have been x equals something else? Does it matter what variable you substitute for? What's the goal with the equation? We need to get it from 2 variables to how many? To 1. It doesn't matter which one. When we start, mostly you'll have slope-intercept form. Then we'll advance, and you'll maybe be given 2 equations that aren't in slope-intercept form, and you can work on substituting that way. It's a progression.
Okay, so we're gonna practice now. Oh, can everyone put your tiles back in the
We'll
bag?
collect the tiles, just put them in the pouches.
Okay, so we have 8 equations, 8 systems of equations on the board. So I want you to all use substitution, the method that we just learned about, to solve these. We're gonna go over, we'll just do the first one right now, and we'll go over it. And then we're gonna have you practice the rest of them, and we'll be around to help you, because this is the first day you're learning, and we don't expect you to know how to do all this right now.
And we're taking the quiz today?
No. So do this first one.
Because you had a test this week, we're not doing it. So do the first one in your notebook, and you can work together while you're going through this. The idea is, what value can you substitute to turn one of those equations into a 1 variable equation? We'll go over, take like 4 or 5 minutes to do the first one. 2x minus 3y equals -1. And then the other equation is y equals x minus 1. We're going to go over this after 5 minutes, and then we'll work on a few others.